What if we told you that everything you know, seconds, meters, the weight of things is based on the limitations of your own body? Our senses evolved for survival, not for understanding the scale of the universe. And yet, the cosmos operates on laws and lengths so extreme they defy human imagination. Today, inspired by the insights of physicist Brian Cox, we'll dive into the scales that govern our universe. From the smallest quantum blips to the vastest galactic stretches. New here, hit that subscribe button and join us on this cosmic journey. The human scale. Why our senses fall short. Let's start with the basics. You judge size by arm's length, time by heartbeats, and mass by how heavy something feels. 1 meter, about the length of your arm. 1 second. The rhythm of your breath. These biological benchmarks are perfect for hunting and building. But try measuring a black hole or a proton with your wristwatch. Our intuition breaks down. The 3 laws that shape reality. To truly understand the universe, physicists rely on 3 pillars: the speed of light, the gravitational constant, and Planck's constant. These aren't just numbers. They're the foundation of all physical laws. Speed of light, 299,792,458 meters per second, a universal speed limit. Gravitational constant, 6.674 times 10. A determines the strength of gravity. Planck's constant, 1.0545718 times 10 cubed J, governs quantum behavior. Together, these constants define everything from black holes to atoms. Speed of light, the ultimate limit. Nothing moves faster than light. It's the cosmic speed cap. In fact, if you could travel at light speed, you'd reach the moon in 1.3 seconds, Mars in 3 minutes, and Proxima Centauri, the nearest star, in just over 4 years. Light gives us the limit of how far we can see and how quickly we can interact with the universe. And due to relativity, time itself slows down as you approach it. The weakest force that rules all gravity. Gravity seems strong here on Earth. Drop your phone and crack it falls. But on the quantum scale, it's laughably weak. A tiny magnet can defeat Earth's entire pull. Yet this weak force binds galaxies together. It shapes planets, steers stars, and creates the monstrous singularities we call black holes. Planck's constant, quantum scale. Now let's go microscopic. Planck's constant defines the scale where quantum effects dominate. It's incredibly small, about 6.6 to 6 times 10 joule seconds. It's how we calculate the Planck length, 1.616 times 10 meters. That's so tiny. A single atom is a giant in comparison. Below this length, the smooth fabric of spacetime becomes grainy, foamy, and weird. Can we observe the unobservable? We'll probably never see the Planck length. It's beyond even our best tech. Why? Because to observe it, you'd need an accelerator the size of the Milky Way. It's the universe's minimum unit of reality where space and time blur into probabilities. A place where gravity and quantum mechanics collide. Within our reach, distances in the solar system, back to our own backyard. The moon is about 384,000 kilometers away. That's a little over 1 light second. Mars, on average, 225 million kilometers, between 3 and 22 light minutes. Voyager 1, launched in 1977, is over 24 billion kilometers away and still sending signals back. Our solar system, once unimaginable, is now mapped and explored. Farther than we can fathom. Galactic distances now zoom way out. The closest star system, Alpha Centauri, is 4.37 light-years away. The Milky Way is 100,000 light-years across. The Andromeda Galaxy, 2.5 million light-years. And thanks to the James Webb Space Telescope, we've seen galaxies over 13 billion light-years distant light that left them shortly after the Big Bang. Conclusion: what it all means, Brian Cox. S message is clear. The universe doesn't just challenge our imagination, it crushes it. From scales that define atoms to distances that span epochs, the universe operates on terms we can barely grasp. Yet here we are, teeny humans, decoding infinity with physics, curiosity, and awe. If you found your mind stretched a little today, give us a like, subscribe for more, and hit the bell icon. Until next time, keep asking big questions.